Hello everyone, I just wanted to stop and make a quick video about the assessment that's due next week. I know there was some questions at the end of class, but we ran up against the ending bell. So what you have to do is you have to start with the spreadsheet heart rate data collection sample. And what you should do is make a copy. So in order to make a copy, we do File, Make a Copy. From here, if you wanted to change this copy of to your name, that would be helpful. Then we know that spreadsheet's attached to you. And what you're going to do is you're going to submit this spreadsheet with your assessment. So you just upload it. So we'll know it's attached to you, but it helps if you have your name. That way, you know, if it's randomly misplaced, we can know it's attached to you. So you hit OK, and it'll make a copy for you. Okay. The next thing you want to do is you want to change the values in the purple table to the ones you collected this morning. So as you update this purple table, the whole spreadsheet will change because it's made with functions. So we can see that each cell is programmed to the data sets above. So update the purple table with your data, and you can answer question number 1. Find the mean, median, mode, maximum, minimum, and range for each data set. Now, all you have to do to answer question number 1 is submit the spreadsheet. That's it. It's automatically programmed in. You're good to go. Question number 2. Create 3 box plots that contain the following data sets. Well, more good news. The statistics are in the first tab named Data, but the box plots are in the following tabs. So submit the spreadsheet, and question number 2 is also answered. Question number 3. It says it wants you to describe what you see in each set of box plots. Use each of these vocabulary words when describing. So we have to describe using maximum, minimum, quartile, and range. So why don't we take a moment to review what those are. So if I go over to resting heart rate, I'm just going to move my picture a little bit. Let's take a screenshot of this and drop it into a whiteboard. Right here. All right, our first vocabulary word is maximum. So just a reminder from class, the maximum is the highest value in a data set. In a box plot, you want to look for one of the whiskers. Okay, so that would be the maximum. Compare both the control to the experimental about maximum. The second vocab word is minimum. Okay, the other whisker, the lower whisker. Remember, if there is no whisker, that just simply means your minimum is equal to a quartile, which is our next vocabulary word. Quartile. Remember, the quartile is the start and end of the box. So the lower quartile is quarter 1, the upper quartile is quarter 3. The other main thing you have to remember here with the quartiles is that 50% of your data is within this box. So when doing that comparison, why is one box smaller than the other? That's something important that you'll have to think about. And you definitely want to mention this whole 50% piece to the data. Our last vocabulary word is range, and you have to remember that range is equal to max minus min. Okay, and how does that change what the box plot looks like as well? So you'll need to compare the resting heart rate, the walking heart rate, and the jumping rope heart rate box plots with regards to those four terms. Okay, next question. The next question is find the standard deviation for each control data set. So, more good news, everyone. If you go back to the data tab, the first tab on the spreadsheet, and you scroll down, we have resting heart rate, walking heart rate, and jumping rope heart rate, and the standard deviation is programmed in for you. Okay, so now based on the data from the purple table, standard deviation, mean, upper bound, and lower bound will all update. Now, what do these exactly mean? So let's take a quick screenshot of our spreadsheet here, and I'll explain what's going on. All right, so here's the data from our spreadsheet. And the mean of our control group is 89.2. That is the middle of our data. Now, in order to calculate the margin of error or the confidence interval, right, we need to add and subtract standard deviation. And this is going to create a margin of error window. Now, lucky for us, we don't even really have to add, right? Because the upper and lower bounds are given to us right here. The upper bound is 99, and the lower bound is 79.4. Okay, so that's our window, right? And what we do is we look at the experimental mean, which is also calculated for you. So the experimental mean is 92. So let's plot that here. So 92 would be right about here. Now let's remember the overall goal of this experiment, right? The experiment was to see if doing a relaxing activity lowered our heart rate for resting, walking, and jumping rope. Well, I can already tell that the experimental mean heart rate is higher than the control heart rate in this data set. Your data set might be different. So this is fairly easy to determine here that it did not have an impact. Let's go over some other scenarios you might encounter. If I have 101, right? Let's say I have 101 experimental mean. That means that my mean experimental heart rate was higher than the upper bound of my margin of error. Well, let's remember the overall goal, right? The goal was to reduce heart rate, right? So 101 would not only would it be no impact, it would actually have a negative impact on the heart rate according to our data, right? Let's go over the other scenario, the scenario that we hope to see, right? Is that, let's say we have 78. Okay, so let's say our experimental mean was 78. Well, one, that's the experimental mean is lower than our control mean. That's good, right? But not only that, but it's also beyond the margin of error or beyond our confidence interval, which tells me that the relaxing activity did have an impact on heart rate, well, for resting heart rate anyway, if that's the one you're measuring. Okay? So the one thing I'll leave you with here, because the last question asks you to just once and for all, does a relaxing activity have an impact on resting heart rate, walking heart rate, jumping rope heart rate? I'll just leave you with this. Whoops, wrong one. Is one standard deviation gives us a confidence interval of 68%. So we are 68% confident that the heart rate, a resting heart rate in our data set will fall between this interval. Use that value when explaining why 78% or 78 beats per minute has an impact. Okay, so I'll leave you with that. That's kind of the confidence measure that we wanna use. I hope this video helps. Of course, if you have any additional questions over the weekend, just send them my way and I'll respond back with some helpful information. Thanks.